What's up, kiddos? How you doing? Good to talk to you again. I hope everything's going well, and I'm going to take you through some notes today. In 10.4, we're going to find area of a regular polygon. So we're kind of getting out of circles, pretty much entirely. Actually, we're done with circles for new sections anyway. And we're going to find area of polygons now, starting with an equilateral triangle. Okay, so here's the deal though. An equilateral triangle is unique. There's like 5 ways to find the area of an equilateral triangle. So I'm going to go here, and first I'm going to draw this. If you were given an equilateral triangle, and you're given a side, and you're asked to find the area, okay, probably the easiest way to do this from prior knowledge is to, okay, so the area of a triangle is 1/2 base times height. Okay, you have the base of the triangle. The base is 6. That's what it's sitting on. The height, though, is not 6. The height is this line right here. Okay, but what's awesome about an equilateral triangle is all the angles are 60. 60. This top one is 60 as well, and it's broken into two 30-degree angles. So now what you have here is a 30, 60, 90 triangle where this little guy right here is a 3. Okay, and remember that was L. This was 2L, and this was L root 3. So being able to find the height is actually going to be 3 root 3 here. Okay, and the area then would be 1/2 times the base, which is 6, times 3 root 3, which is the height. Okay, and if you do that in your calculator, whoops, do that in your calculator, 18 divided by 2 is 9. 9 times the square root of 3, you can either leave it as 9 root 3 if you wanted to. Come on. Come on. Oh, gosh. Uh-oh. We might be pausing this video for a minute. These are all straight. There we go. Okay. 9 times the square root of 3, or you can write it as a decimal, which is like 15.6. So either way, 9 root 3 or 15.6 units squared. Okay, now that's probably the way that I would do it, but I actually have a nice formula for you that that shortens it up significantly, actually. And here it is. The area of every equilateral triangle, you don't even have to do this 30, 60, 90 principle. It ends up being 1/4 times the square root of 3 times whatever a side is squared. Okay, so if we go back to our same picture here, all right, let's erase this. The area of any, this is only for an equilateral triangle, by the way. So the area is equal to 1/4 times the square root of 3 times 36, and what do you know? It also gives us 9 root 3, which is equal to 15.6 units squared. Okay, so it ends up working out. If you want to remember this formula right here, this is great. You're going to have it, you know, if we ever take a quiz or anything like that, you're going to be able to just use it anyway. So, but if you also wanted to do a 30, 60, 90 rule to find the height and use 1/2 base times height, it's also a way you could find the area of a triangle. So, formula for you for the area of an equilateral triangle. Now let's get into, well, a square would be easy. It's just side squared. But let's get into every regular polygon. Okay, pentagon, hexagon, heptagon, octagon, dodecagon. We can actually find the area inside every single one of these if we're given some information, and I'm going to teach you today how to do that. But before we do that, a little bit of vocab. Okay, here's a pentagon. Okay, some things that you already should know. At the very center of a pentagon, that's called the center. Okay, it's the same distance away from all 5 vertices. Each one of these is called a vertex. You know that by now. Okay, vertex of this pentagon. Here's a couple things you don't know. Okay, if you draw a line from the center to a vertex, this is actually called a radius of the polygon. Radius. Come on. Radius. It would be the same as drawing the radius of a circle that had all these wow, I did a pretty good job there. All those vertices on the circle. Okay, so it would be the same line. Okay, but radius of the pentagon goes from the center to a vertex. And here's another line that you don't know quite yet. This guy right here. If you draw a line from a center to the side at 90 degrees, you could draw 5 of them, by the way. Here, I could draw another one up here. Okay, it'd be the same thing. This is called an apothem. This is weird. You probably never heard of this before. Apothem, A-P-O-T-H-E-M. Write that down. Okay, and we actually need this apothem because here's the deal. When we look at regular polygons, guess what, guys? There is just a certain number of right triangles all put together. So basically, I'm going to give you a formula that's going to add up. That's going to add up every single one of these right triangles, and it's going to then obviously equal the area inside that pentagon. Okay, now we're not going to take every individual triangle and add them together. I'm going to give you a formula here for the area of every single regular polygon. Has to be regular, meaning all 5 same sides, all interior angles are the same, just like so. Okay, and here's the formula. Write it down with me. Okay, the area of a regular polygon it is equal to 1/2 times the apothem's length times capital P, which is the perimeter around the figure. So that is apothem. This capital A, that's area. This lowercase a, that's apothem. And this P stands for perimeter. Now, why would the perimeter of a figure be in the area formula for the area of it? And the reason why is because base. Every one of these right triangles, if we were to do 1/2 times base times height, okay, every one of them would have have a certain base, and all the bases added together give us the perimeter. That's why this formula right here, the area of a regular polygon, has the perimeter in it. Okay, so let's get right to work and let's use this thing. Okay, let's go with, if we have a pentagon, and here's what's nice. If they give us, let's say, a side length here, I'm going to do some math so I don't mess up what the apothem would be, because it turns out if you have a length of 5 as a side and you're a pentagon, the apothem can only be 1 length if it's regular. You can't just put in 6 or 7 or 8 or whatever you want to, because that would obviously throw off if it was regular or not. So let me do something real quick. Okay, 36. Okay, so the apothem in this case would have to be 3.4-ish, okay? So if I'll show you how to get that, but let's say we were given this problem. We were just straight up given this problem as an example, and it said find the area. It gives us a side length, beautiful. It gives us the apothem's length, beautiful. Plug it in. Area is equal to 1/2 times 3.4 times the perimeter, which would be all 5 sides, each a length of 5, 25. So 1/2 times 3.4 times 25, and just multiply it together. 3.4 times 25 divided by 2. Okay, the answer here would be 42.5. All right, units squared would be the area inside this shape. If you have the apothem and the perimeter, you just plug her in. Okay, let's get a little bit more difficult though, because sometimes they're only going to give us like a side length or just the apothem, or maybe sometimes they're only going to give us the radius of a shape, and then we will end up having to do a little bit of math here, and I'm going to show you how to do that. So let's do an octagon. I give you an octagon, okay, and I'm going to give you a length. That's a length of 6. And that's all I'm going to give you. And I'm going to say find the area. You can do this. I'm going to show you how. Find the area. Am I doing on time? 9 minutes, 10 minutes almost. Okay, good. Find the area. Okay, here's what we're missing. We're missing the apothem. Because 1/2 times apothem times perimeter. The perimeter is going to be easy. There's 8 sides. They're all 6. The perimeter is 48. Okay. Here's what we're going to do when we find the apothem. We're going to draw the center. We're going to drop that line down. And we're also going to draw the radius. And I'm going to show you why. Because what happens here, I'm going to take this and draw it out here. This is now a right triangle where this we don't know. That's what we're looking for right there. This is now 3. That apothem is going to cut the side in half. And actually, we know what angle that is in there. Okay, I'm going to show you how we can find that angle. If I were to draw, let's say I were to just draw this angle right here. This is called a central angle. I want everybody to write that down. If you just draw a radius and another radius, that's called a central angle. Okay, you can find a central angle because there's going to be 8 central angles in an octagon, and all of them have to add up to 360. It kind of goes in a circle. So if you took 360 divided by 8, okay, a central angle of an octagon is going to be 45 degrees. Okay, wow. Well, now this angle in here is not a central angle. It's half of a central angle, right? Notice if I were to draw the full central angle down here, it would be this whole angle, which is 45. This angle right in here, which is also this angle right here, is actually half of that, which is 22.5 degrees. Okay, 22.5 degrees. So now if I write this as x, that's my apothem's length, we're just going to do a little trig, right? We know this angle. We know the opposite leg. We want to know the adjacent leg. That's a tangent ratio. The tangent of 22.5 is equal to 3 over x. And as we remember, when our variable's in the denominator, you can just switch that in the tangent of 22.5. So 3 divided by the tangent of 22.5, that's going to give us what our apothem is, which in this case is 7.24. That's the apothem. Okay, we found that. We're going to plug that into our formula there. The perimeter is going to be 48. It's going to be 6 times 8. So each side is 6. There's 8 sides, 48. Okay, so the area is 1/2 times 7.24 times 48. Jeez Louise, that's messy. Sorry. Get that out of your way. 1/2 times 7.24 times 48. Okay, let's do that calculation. 0.5 times 7.24 times 48. And it gives us 173.76 units squared for the area inside of there. Okay, 1/2 times apothem times perimeter. We used a little trig. We pulled out a little triangle here and we used some trig. We're going to do one more problem, then I'll set you free for the day. We're at 13 minutes. One more problem. Okay, let's draw a hexagon. I'm going to give you the apothem. I'm going to give you the apothem, and that's all I'm giving you. This guy right here, let's go as 10 centimeters. Okay, so now, area, 1/2 times apothem times perimeter. Beautiful, we have the apothem. Here's what we don't have. We don't have a perimeter because we don't know a full side lengths. So the first thing that we're going to do is we're going to draw a little triangle in here. Watch this. Okay, I'm going to draw this triangle with the apothem, with half of a side length, and with a radius, just like so. And I'm going to pull it out. All right, that's 10. I want this guy right here because that's going to help me get to the perimeter. I also know this angle right here. How do I know this angle? Well, a full central angle of a hexagon. There's 6 central angles in a hexagon. So 360 divided by 6 is 60. So 60 degrees is a full central angle of a hexagon. So this guy right here would be 30. It's half of a central angle when you draw that right triangle. Okay, you can either use 30, 60, 90 rules, or it might be easier just to use trig here and write it as a decimal. Okay, this is also a tangent function. The tangent of 30 equals x over 10. Okay, so x then would equal 10 tangent of 30, which is 10 times the tangent of 30 is 5.77, blah, 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 blah. Okay, now, that's not a full side length. That's half of a side length, okay? It's not the full perimeter, not even close to the full perimeter. So we're going to double that to get to a full side length, 11.5. And then we're going to take it times 6 to get to the perimeter. So that means now the perimeter then would have to be 69.28 whatever, centimeters, okay? So that's what we're going to take, and we're going to plug into our formula with the apothem that they gave us. Boom. Okay, and our final answer is going to be 1/2 times 10 times 69.28, and that's 5 times 69.28, which is 346.4 centimeters squared. Okay, so some problems today are going to be easy. I'm going to straight up give you a side and the apothem. Bingo, plug it in, plug the perimeter in, plug the apothem in, and go. Some are going to be more difficult. You're only going to be given one thing, and you're going to have to use trig and a triangle to get to what else you need. All right, good luck, do your best. Email me with questions, otherwise we'll Skype tomorrow. Peace.